it is not wrong. Or there's still more than this under. Let's say I will say that negative. Okay, I will say, hold on now, let me see. I can say 16 to the power of negative 2 equals to 4 to the power of negative 4. Right? 16 power negative 2 is 1 over 256. This is also 1 over 256. Okay, you can keep on going. That's why I say you have more than one answer. Question E. Anyone got any answer for E?
1 over of 27, 3 to the power of negative 3.
Yes. Okay. Or you can write it as this one, 2 to the power of negative 3, or 1 over 64 equals to 4 to the power of negative 3. 4 cubed is 64, if I'm mistaken. Yes. Or 100 over 1 over 125 equals to 5 over 5 to the power of negative 3. You can keep on going. Question C. Chiang, do you get the answer?
No.
Okay, anyone got any answer for C?
2 to the power of negative 3. 4 to the power of 2.
1 or 2? Because you see, 5 minus 3 is 2 square, isn't it? 2 square, it means 4. Okay? You can also say that 2 to the power of 5 times 2 to the power of negative 1 is equal to 2 to the power of 4. 2 to the power of 4 means 4 squared. Okay? Or you can say 2 to the power of 5 times 2 to the power of negative 5, you get 4 to the power of 0. Or 2 to the power of 5 times 2 to the power of negative 7. Okay, then you get 4 to the power of negative 1. 2 to the power of 5 times 2 to the power of negative 9, you get 4 to the power of negative 2. And you can keep on going. Okay, do you all understand this question 8 ABC? Okay, so next. Okay, next is about rational and irrational numbers. So basically, when we say natural numbers, we are saying that positive integer. We do not include 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. We call it natural numbers. Then natural number, and then another things is we call rational numbers. Rational numbers means numbers that can be written as fractions. Okay, number that can be written as fractions. Example, 3 is a rational number because I can write 3 as 3 over 1, 6 over 2, 9 over 3. All these are fractions. Because fractions, I have improper fractions and proper fractions. These are all improper fractions. So as long as I can write the number as a fractions, it is a rational numbers. Okay, numbers like 0.333333, So this one, we call it recurring decimal. That means the 3 never end. This one, I can write it as fractions. It is 1/3. Okay, it is 1/3. So this one is a rational numbers. Okay, like 0.125. You can rewrite this into 125 over 1000. If you simplify it, you get 1/8. So this one is also a rational numbers. Okay, decimal, this one we call it terminating decimal. That means it will not be recurring. Okay, it will not be recurring. Then we call it terminating decimal. So we can rewrite it into a fractions. Okay, as long as it is not recurring, all the decimal number can be written as fractions. So now the question here is, how do I convert this type of recurring decimal into a fractions? Okay, let me show you an example. Let's say I will write 0.225225225225225 and so on. Okay, so how do I write this as a fractions? So I can say that I let x to become 0.225225225. Right? So my objective here is to figure out a way to cancel out all the recurring numbers after the decimal point. So if x equals to 0.225225225, 100x means 225.225.225.225 and so on. Am I right? So I can say that 100x minus x is 225. Because the numbers after the decimal point all gone. Because 225 minus 225, 225 minus 225 all gone. So balance I have 225. So 100x minus x is 99x is 225. Then I can write x is equal to 225 over, sorry, not 100, it's 1000, my bad. It is 1000. So it should be 1000. You times 1000, you get this 225 point this. So it'll be 1000 minus 1000x minus x, you get 999. So you get 225 over 999. If you use your calculator, key in this 225 divided by 999, you will get this 0.2292292229. 225, okay? This is the method, okay? We convert the recurring decimal back to fractions. Okay, we can convert the recurring decimal back to fractions. When we can convert it back to fractions, I can say that this one is a rational number. Okay, so when numbers that can be written as fractions, we call it rational numbers. Numbers that cannot be written as fractions, we call it irrational numbers. Example, square root 2. If you press your calculator, square root 2, you should get 1.41 4142 and you will never see any repeating numbers after the decimal point. So if there is no repeating patterns, we cannot use this method.